My name is Nur Anis Patricia binti Zulkarnain.
My name is Nur Danajo binti Zapidi, and my student number is 2024-205918.
Yo, what's up guys? Assalamualaikum warahmatullahi wabarakatuh. My name is Adam Safran bin Abdullah. Hello and Assalamualaikum. My name is Muhammad Ahmad Irfan bin Joshua.
And hi, my name is Nurgarish Wazrin binti Muhammad Soimi.
So today I'll be talking about derivative. So what is derivative? Derivative is the rate of change of a function with respect to a variable. Derivatives are fundamental to the solution of a problem in a calculus and a fundamental equation. And there's two types of derivative, which is first derivative and second derivative. And also, derivative is the rate of change of a function at a specific point or the slope of the tangent line to the function graph at that point. And did you know that differentiation is the process of finding the rate of change of a function with respect to another quantity?
Differentiation in business. What is differentiation? Differentiation, or another word, is finding the derivative of a function. It's a fundamental concept in calculus that describes how a quantity change as another quantity change. In simple terms, the derivative measures the rate of change of a function with respect to one of its variables. In the business world, differentiation plays a crucial role in helping business make confirmed decisions, whether it's maximizing profit, minimizing costs, or optimizing revenue. Derivative provide valuable insight into how small change in variable can significantly impact business outcomes. Understanding the rate of change in areas such as production, revenue, cost, and profit is essential for making strategic and efficient business decisions.
Now, I will explain about function of derivatives in business. Derivatives are used in business in a variety of ways, including the first one, profit optimization. It helps businesses understand how to increase or decrease prices to increase revenue. They can also help businesses to find the maximum and minimum profits. The second one is risk hedging. It is used to offset potential losses from an investment by taking an offsetting position in another market. For example, derivatives can be used to hedge against interest rate risk, currency risk, and commodity price risk. The third one is pricing and output decisions. It can help businesses to determine the incremental costs and revenues and marginal product of the factors employed in the production process. This can help businesses make decisions about pricing and output to optimize profits. The fourth one is stock price changes and interest rates. Differential calculus can be used in business and finance to solve problems such as stock price changes and interest rates. Derivatives can also be used to find the rate of change in quantity of a product in respect to other quantities. The derivatives are used in business management as a way to optimize profits, since the derivatives help with understanding the methods of increasing or decreasing the price of commodities for increasing revenue. It helps to solve problems of finding the maximum and minimum profits. The business companies use the method of cost function for setting the prices of the commodities. They are able to derive the cost when the marginal cost is given and to derive the revenue when marginal revenue is given.
Example question 1. Maximizing profit. One of the most common uses of derivatives in business is to maximize or minimize profit. A business typically wants to maximize its profit by finding the optimal level of production or sales. By using derivatives, businesses can find a point where the rate of change of profit with respect to the production or sales is zero, which indicates the maximum profit. Problem. A company's revenue Rx from selling X units of product is given by the function Rx equals to 500X minus 3X to the power of 2. The cost of producing X units is represented by the cost function. Cx equals to 200X plus 1000. Find the number of units X that the company must sell to maximize its profit. The solution? The first step is profit function. The profit is given by Px equals to Rx minus Cx, which is 500X minus 3X to the power of 2 minus 200X plus 1000. We should simplify the expression. Px equals to 500X minus 3X to the power of 2 minus 200X minus 1000, which we will get negative 3X to the power of 2 plus 300X minus 1000. The second step is to find the derivative. To find the maximum profit, differentiate the profit function, which we will get negative 6X plus 300. The third step is to set the derivative equal to 0. Set the derivative equal to 0 to find the critical points. Negative 6X plus 300 equal to 0, which we will get X equal to 50. Step number 4, verify the maximum using second derivative. The second derivative is negative 6. Since it's negative 6 is negative, the function is concave down, so X equal to 50 gives a maximum profit. Conclusion, to maximize profit, the company should sell 50 units of product.
I will be discussion to you guys about example 2, which is maximizing revenue. So the problem is, a company is a selling product and the demand function is given by Px equals to 100 minus 2x, where Px is the price at which the product is sold and x is the number of units sold. The company's total revenue function is Rx equals to x times Px. Find the number of unit x that minimize total revenue. So as for the solution, first one, you have to find the revenues function. So revenue is Rx equals to x times Px. So Rx equals to x times 100 minus 2x, and we will get 100x minus 2x to the power of 2. So as for the second step is, you have to find the derivative of the revenue function. So r prime x equals to dx over d, with the bracket 100x minus 2x power of 2, we will get 100 minus 4x. So as for the third step, we have to set the derivative equal to 0. So basically on the second step, we find the derivative, right? So the derivative that we find early is 100 minus 4x. So it will be like 100 minus 4x equal to 0. And to find the x, we will rearrange it and we get the x as 25. So number 4, which is the last one, is verifying the maximum using the second derivative. So second derivative is r. We have to differentiate r 2 times and we will get the derivative equal to negative 4. And since r prime is equals to negative 4, which is it's a negative, the function is concave down and x equal to 25 give a maximum. So as for the conclusion, the company should sell 25 units of product to maximize revenue.
So for the example question 3, revenue optimization, the problem is a company's revenue function is given by Rs equal to 50x minus 0.5x power of 2, where S is the number of units sold. What quantity maximizes revenue for the company?
So did you guys know that revenue optimizing is basically the derivative of the revenue function, which helps business understand how change in pricing or quantity sold impact revenue. Finding where the derivative is zero can indicate the price of quality and maximize revenue.
So there are 4 steps to find the solution. The first one, find the derivative. To maximize the revenue, first we need to find the critical point by differentiating the revenue function of Rs with respect to x. So r prime s equal to d over dx in bracket 50x minus 0.5x power of 2. So we get the answer is 50 minus x. Second, set the derivative equal to 0. R prime s equal to 0. And then we get the 50 minus x equal to 0 and then x equal to 50. So for the third one is verify the maximum using the second derivative. So r double prime x equal to d over dx in bracket 50 minus s. So we get the answer is negative 1. Since r double prime s equal to negative 1, which is a negative, this means the function is concave down and that x equal to 50 is indeed a maximum. So for the last step, we need to find the maximum revenue. We need to calculate the maximum revenue by plugging s equal to 50 back into the revenue function. So r in bracket 50 equal to 50 multiplied by 50 minus 0.5 multiplied by 50 power of 2. And then we get 2,500 minus 1,250. And then we get the answer is 1,250. So the conclusion is the company maximizes its revenue when it sells 50 units and the maximum revenue is $1,250.
Last but not least, differentiation is business strategy that can help companies stand out from their competitors and achieve success. The conclusion is that differentiation can lead to a number of benefits, including increased market share, higher profit, improved customer loyalty, enhanced valuation, resilience to economic downturns. In conclusion, differentiation is a powerful tool in business field. By understanding the rate of change in key business functions such as cost, revenue, and profit, businesses can make strategic decisions to optimize their performance. From maximizing profit to minimizing costs, derivative offer essential insight that help business thrive in competitive markets.